Hey guys, it's Curtis here today, and I'm going to be explaining our final price for AP Stats, but first, memes. You are a queen, and we will show you the way. Since being introduced to the candy market in 1941, M&Ms have been a main seller in the candy industry for several decades and a common source of cavities. I eat. M&Ms are also a favorite among people, as a box of M&Ms generally contain a large quantity of the candy, unlike certain brands of chips that advertise bags of air. Lays. A standard 3.1 ounces box of M&Ms that are sold in usual grocery stores claim to contain 87.9 grams of the delicious treat. And this, we think, is full of lies. The legitimacy of this claim by the company is exactly what our team questioned. So in this study, we will be examining how much the absurd mean of the net weight of the box of M&Ms deviates from the stated net weight on the box. Originally, we were planning to do our project on Lay's chips, but we ran into a problem which we'll later discuss in the video. We used the Lay's website to determine which stores to go to, since they list all the stores that sell Lay's chips within a 6-mile radius. For a random sample, we numbered each store from 1 to 26, and using our random number generator with a range of 1 to 26, we generated 5 different values, ignoring repeats of course. The 5 stores that correspond to the produced values were Sharpie Stanley, Vaughn's, Plaza Wine and Spirits, Rite Aid, and Shell Oil. Can't forget about Shell Oil, can we? However, we knew there was trouble when we first walked into the store and saw that they only had party-sized bag of Lay's, not the normal ones, you know? It would be impossible to finish all 30 party-sized bags of Lay's chips in one day. It would take at most 3 days. We got to the second store and we encountered the same exact problem. Faced with this dilemma, our team decided to instead work with M&Ms, another one of our childhood favorites. Fortunately, this change in our decision wasn't a tough one. At the store, we also had to randomly select the boxes of M&Ms. Similarly, for each store, we numbered all the boxes of candy and used a random number generator to help us determine which 6 boxes to buy. After buying 30 boxes of M&Ms we needed, we measured the mass of all the candy inside each box, ending up with a mean net gain weight gain of 92.61 grams for one box of M&Ms. We performed a 1 sample t-test for means for a significant value of alpha equals 0.05, and we ended up with a p-value of 1.5147 times 10 to the negative 11th, which is a very small number, leading to us rejecting the null hypothesis, since the p-value is significantly smaller than this significance value. Additionally, we established a 95% confidence interval for the true mean net gain of the candy inside a box of M&Ms. And this confidence interval was 91.7065 to 93.5135. This meant that the most M&Ms actually contained more M&Ms than advertised, which was very interesting. However, we also encountered multiple sources of error, one of them being that M&Ms have only been measured only once. So if a person who measured the M&Ms forgot to zero out the scale, did not empty out the containers completely, or measure under such conditions that made the measurements slightly heavier or slightly lighter, there was no way of us catching the errors in measurements. Despite these sources of error, we can say that we are 95% confident that the interval from 91.7065 to 93.5135 grams captures the true mean net weight of a standard box of M&M's candy. We had a lot of fun with this project, and we would like to thank Riley for being the only one with a car to drive us places. We also enjoyed eating 30 boxes of M&M's. Thank you for watching. Peace. Make sure to like and subscribe, guys.